So 3.3 starts us off with a getting started question about hailstones. This one's kind of like your physics questions in that they're just giving you a formula, giving you some variables, and asking you to figure it out. So they tell us that the terminal velocity of a hailstone can be determined by using v squared equals 2 million d, where d is the diameter in centimeters. So we can just write that in. That's an M. And remember that the terminal velocity is the speed that it's going to reach and stay there because its acceleration due to gravity has been canceled out by the air resistance that's built up. So they tell us that the d we're going to use, the diameter, is 10 centimeters because that's the largest hailstone ever recorded. Now, 10 centimeters, use our little measuring stick here, is that big. So that's a pretty freaking big hailstone. Let's see how fast it went. So we just take d, plug it in where it is in the formula. We're ending up with 2 million times 10, which isn't very exciting. We just add another 0. But because this is squared, we're now going to have to take the square root of both sides, or whichever way you want to look at it, but you square root a square to get rid of it. So that leaves v on this side, and 4,472 centimeters, this is actually per second, as the speed. So you could convert that to something that's easier to look at. Centimeters can go into meters by just moving it 2 spaces, and that's approximately 45 meters per second. Pretty freaking fast. Oh, one final note. The square root could have been a negative, right? Because negative 4,472 times negative 4,472 would have actually equaled the same number because a negative times a negative is a positive. So you always want to look at your square roots and ask yourself if it makes sense to use that negative number, because the negative and the positive are both possible. But in this case, unless your hailstone is accelerating upwards into space, then we could just disregard the negative one and go, yeah, the positive one makes sense, the negative is extraneous.